Hello there, everybody. I, like many others on the interwebs, have been inspired by the work of Mr. Ben Eater and his 8-bit breadboard computer, so I'm going to jump in and start making my own. I'm going to do some things slightly differently, which is going to be what I'm mainly talking about in this video because he does a great job of explaining most of the concepts, so I won't be repeating what he says. I've already gone ahead and built the clock module, which is this. Again, you can see it's on Perfboard, not on breadboard. I started off on breadboard, but moved it to Perfboard. It's got the same functions. This is a 74LS. This is a 556, which is two 555 timers, and I also have a selector instead of the and NAND gates. So I can give you a description of this later, but this is not the focus of this video. What I want to focus on for this video is a build of the program counter, which he did, because I'm going to do it slightly differently. He did a 4-bit address. I'm going to be doing an 8-bit address register. So I will be also using the 74LS163, which is the same thing that he used. But I will be just using 2 of them, and I'll be doing some things slightly differently. So this is the data layout for the pin layout for the 74LS163. Some key features, obviously, there's an enable pin here. That should be actually an active low. The 4 bits, the clock, the clear line, also active low. It's got a load function, which is an active low, which we'll be using for our jump function. And the most interesting part of this is how you can make it into an 8-bit adder, is with these 2 here, the carry in, what I'm calling carry in, carry out. So this is enabled when all 4 of these are enabled, so it's showing 15. And if this is enabled, this has to be enabled for the chip to be counting. So I can show you basically if we have, the reason I've done it like this is because I want to daisy chain 2 of these together. So we can daisy chain a second one in here. 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to bother building the whole thing out, but essentially this is the same. So I do it backwards instead of doing the traditional left-right, because I'd like to have the least significant digit on the right, the way we're normally seeing binary. So if this is the carry out and the carry in pins, on the low ones, the carry out, this carry in will always be taken to ground because it's an active low. And this will go high once this is 15, which ties to this line. So this line will always be low, meaning it will ignore all the clock pulses until this goes high on 15. So the next clock pulse, this will go to 0, and this will increment by 1 because this is pulled high temporarily. So as soon as this goes to 0, this goes to 1, and then this will go low again, and this will wait for another 15 cycles of the clock. So as an example, let's say we had, our 6 digits was 1, 2, 3, 4 was in this one, and then 1, 2, 3, 4 is in this one, showing 15. To get to 16, this goes high, and then these all will reset on the next clock pulse. This will count by 1, and then this will go low, and then the next clock cycle, this will count by 1, 0, 0, 0, 1, 0, 0, 0, and so on and so forth. So essentially, you daisy chain them together by putting the out to the end of the next digits and tying the clocks together. So the clocks are tied to the same clock. And so that's what we're going to build. So we'll do it on a breadboard first, and then in the next video, I will transfer it to a Perfboard. So let's get started. Okay, so I have my breadboard here, just some power lines wired up to it. And I have my 2 74LS163s. Then I'll pop in here. Okay, let's wire up ground and power on both of them. Okay, so we got a ground and power wired up. Let's wire up our, let's do our enable pins next. So like I said before, the lowest significant bits will be this one. So this will be the first 4, or the lowest 4 bits. So for that, the jump or the carry and the enable flag, actually I made a mistake on this diagram too. This enable is an active high, not an active low. So that is an active high. So I need to tie both of those to 5 volts. And on the second one, I want to tie the enable flag high but I want to carry over the carry out of this one to the carry in of this one. Okay, so now when that's high, that will enable that one. And that will already pull it low, so I don't need to pull that one low. I also want to tie our 2 clock lines together, which was pin over here to that one. So the clocks are tied together. So looking at that, that's pretty much what we wanted to wire it up on, I think. Oh, on the clear, I need to tie the clears low. No, it's active high, so I need to tie it high, active low, and tie that high. Okay, that's tied to 5 volts. Okay, so let's for now put an LED on each of the outputs. Okay, so now all 8 outputs are wired up. And the load, for now I'm just going to tie the load signal on both of them to, now again, the load will be our jump, right? So this pin here is eventually be our jump, which means load from the bus. But right now we want them to be not loaded, just counting. So tie both those to high. Okay. All right, so that looks reasonably good. I should be able to attach a clock and power now, and it should count. Let's see. So looks like my power cables here. And my clock into the clock. And nothing. Make sure my power lines are all good. Oh, loose power line, that would do it. Okay, so I don't know how you can see that with the light. But if I hold it on the side like this, you can see once it gets to 15, it counts one over to the second counter. Oh, now it seems to be shorting out on something. One of the jumpers isn't quite in there well enough. Oh, that's why. All the LEDs are shifted over by one. That makes sense. Let me pull the power out for a second. So you can see I've tied the first LED to the second pin. I can't, and I can. I just tied the LEDs into the wrong order, so let me fix that. Okay, now let's try it. Turn the clock up a little bit. That looks a lot better. Perfect, all right. So that appears to be working reasonably well. Now the next thing we have to do is build the selector circuit so that I can select a manual location instead of just a location from counting. So I'll insert one of these dip switches so we can, and some selectors so we can manually do that. Okay, so we're going to follow the exact same method that Ben used. We're going to use these two 74LS 157s, which he used one. I'm going to use two because I have 8 lines. So they're just the 2-to-1 selectors, 4 of them. So let's put that here and here. So if we look at the data sheet for these, they're pretty simple, VCC and ground, and they have 4 sets of inputs: 1, 2, output, 1, 2, output, 1, 2, output, 1, 2, output. And then we have an enable signal as well. So this is your selector, whether or not you want the A's or the B's. So we're just going to hook all of our counters up to the A's and our dip switch up to the B's. And then I'll put a little jumper onto this select. So let's do the VCC ground and enable first, and we'll go from there. Okay. Add our selector. We'll do the same thing Ben did and do the upside down method, because it is confusing to push down for on. So let's start by pulling out these. We don't need these right now. So instead we're going to start with our data lines. So we want all the outputs of this over to here. So I'm going to use blue for that. Before I start, I also want to link the output, the select pin 1s on both of these to each other. So the selects are tied together. Okay, so that's all of the A inputs. So I'm taking, this is the upper bits. So, sorry, this chip is for this one, this chip is for this one. So that's just how the wires worked out. So now I need to take the corresponding values from here and put them into the B's of all of these as well. So the first bit here will actually be the first bit of this one. So 1 goes to here, 2 goes to here, 3 goes to here, 4 goes to here, 5 goes to here, so on and so forth. You get it. It's gonna get pretty tight. Okay, so I'm not really sure how Ben makes it look so easy, but fitting all those little wires into breadboard is not easy, and came out with a video today saying how good breadboards help, and this is not a good breadboard, this is a cheap one. So I managed to get them in. Just to run you through what we have here. I have the lowest bits coming out into 1, 2, 3, 4 into this chip. The higher bits 1, 2, 3, 4 into this chip. Then in the yellow, I have the lines from the dip switches coming into, same thing, 1, 2, 3, 4, 5, 6, 7, 8, and then the white is the selector. So actually, speaking of selector, let's insert the selector. I tied them together earlier. That's pin 1, so I'm going to put this selector jumper in. Let's start with tying it high. So yeah, I'm not sure if it's A or B, but we'll see in a second. And then I have all the LEDs in as the output. So these are all grounded, and then the results in the white come here and then come into these LEDs. So let's give it power and see how we did. Put the clock in. And power. Okay, don't see anything yet, but that's not that unusual. Let me flip some of these dip switches and see. Okay, so we do have results on those ones. Got all 4 of those, but these ones have no effect. Okay, so at least these 4 are working. Okay, so let's see what we've done here. Clearly, take the power off. Clearly something wrong with this second selector. It has power, it has ground, yep, and then the enable jumper is in the wrong place, so that should be high and it's low. That would do it. Plug back in again. That looks more promising already. So if I flip these two up, okay, we got all except for one, huh? Okay. Let's see what's wrong with that one. Okay. Alright, so the operand is working. I see my white wire is the issue. So what's wrong with my white wire? It's in the right place. Right? Yeah. There we go. It's just in the wrong spot. Okay, so now all of our dip switches seem to work. Not bad, okay. And now if I switch it to counter mode, let's see if it's able to count with the clock. Oh, I gotta put the clock in, I think it usually helps tremendously. Okay, yeah, sorry, I know it's hard with these non-dim LEDs, but look, that seems to be counting up correctly. Yep. Okay, so we're now able to select between manual mode and non-manual mode. And now one last thing we haven't tried yet. Let's put it back off for now so you can still see. I should be able to load from this. So right now the load pin, if we go back to our schematic, the load jump is pulled low. Let me switch that with no, it's pulled high. So yeah, I pull the jumpers out. Instead, I'll just put these in for now. I'll put them high again just to make sure we haven't broken anything by pulling that out. So now if I go back into count mode, this will be counting. With the clock on, of course. Okay, good. So now, if I switch these to this, it should go into load mode, which will not be counting. Oh, it keeps loading in the same thing over and over again, so it's all high. That's good. So now if I pull some of these, because these chips float high, so it's not surprising that they all have ones in them. So if I put one random bit on each one to low from the load pins, these will connect to the bus on the jump command. So I pull that one low, and I pull the highest bit here low. Okay, now the clock pulse. Yep, those two are low, see? Sweet, so if I switch the highest one here to the second highest one, and pulse the clock. I can't see that, can you? So I haven't pulsed it yet. You can see that second and the 8th bit. Now if I switch, it should be second and 7th. There you go. Okay, so the jump command is also working as well. That's annoying. So good. Looks like we have the good starting workings of my program counter. Now, what I plan to do next with this is put it into a perf board, which will be hard because there's a lot of connections, as you can see, but This wasn't easy because of all the wires and nesting them in there with the sizes. So I'll have to design a layout for this, and then we can do a lot of soldering in the next video. Thank you. Take care. Thanks again, Ben, for the great tutorials. You really inspired a lot of people, and that's awesome.